Okay, so we are starting the ionic bonding notes, and today we're going to start off with the definition of what an ionic bond compound is. So an ionic compound consists of a metal, cation, bonded to a nonmetal, anion. The electrostatic attraction holds them together. The ionic bonds are kind of like saying transfer of electrons. That's basically what's happening. Now, another thing that we have to pay note to is what a binary compound means. Bi meaning two, so in a binary compound is one that is made up of just two elements. So if you notice on the bottom right-hand corner of this of the screen, you notice it says NaCl. Well, NaCl, sodium chloride, is a binary compound, binary ionic compound. Now, what does it look like in a reaction itself? And I'm sure you've seen the reactions before. So, in a reaction, this green little box here, it shows you how sodium and chlorine are coming together. But if you notice the arrow going from sodium, one dot or electron, is being transferred, that's what that arrow means, transferred over to the chlorine. And then on the right hand side of the arrow, you notice that now sodium has a plus sign. And that just means that sodium lost an electron to chlorine. And if you notice on the chlorine, it has a negative sign, and that's because it gained the electron. So let's go a little bit further into this. So metals are on the left side of the periodic table. They tend to give up electrons. Giving up an electron, which is a negative charge, makes the element a positive ion. If you're losing a negative, you're becoming more positive. That's why it has that positive sign. Now, nonmetals, they're on the right side of the periodic table, and they tend to take electrons from metals to complete their outer shells. Adding an electron makes the element a negative ion. Now, we're going to label our periodic tables. So get your periodic table on the bottom or in the middle that you see in the middle of your notes. And we're going to label it. So one thing that we have to remember is that ions form by gaining or losing electrons to become more stable. Now, when you lose an electron, you become positive, and this positive is going to be called a cation. Now, as the little box with the little kitty cat on there, it says cation, and it's pronounced cation. It's an ion with a positive charge, the cutest ion ever. Then, if you gain an electron, you become negative or an anion. So on your periodic table, you're going to put a +1 on the first column on the left-hand side, the alkali metals, and also around the hydrogen, because these are going to lose one electron, or tend to lose one electron. Then above the alkaline earth metals, we're going to put a 2+ because now in this section, these want to lose or transfer 2 electrons. We go straight across. We're going to put a 3+ in the boron family. And this boron family, we're going to transfer or lose 3 electrons. That's how many it wants to lose in order to become stable itself. All right, then you're going to put, I have a 4+ / right above the carbon family. Why? Well, you have to realize that in the carbon family, you have two situations. Now, for us, in this class, we're going to tend to look more into carbon doing a lot of the bonding. So we're going to be dealing more with the 4 minus, okay? So just so that you know, it can be a plus or it can be a minus in this one. Right above the nitrogen family, we're going to put a 3 minus, meaning that it needs to gain 3 electrons in order to become like the noble gas and stable. Above the oxygen family, we're going to put a 2 minus, because again, it needs to gain 2 electrons. And then above the halogen family, we're going to put a 1 minus because these need to gain 1 more electron in order to become stable and, like the noble gases, a complete octet. Above the noble gases, we put a 0 because they're stable as is. They don't have to worry about gaining or losing anything. They want to be just as is. All right, so let's keep on going here. It says the binary ionic compounds. Again, we're talking about a compound that has 2 elements together. The metal cations in these compounds have only 1 possible charge. So sodium has a +1, zinc has a 2+, aluminum has a 3+, calcium has a 2+. Now, the charges are memorized or predicted using the periodic table. Okay, so those are the numbers that we were just writing above the families just a little while ago. You're using those numbers so that you can actually combine them in the bonding situation. Now, for most of the transition metals, we're going to say it's a 2+ for right now. Okay, we'll talk more about that later. The cations, on the other hand, are bonded to a nonmetal. You have oxide, which is a 2-, nitride, which is a 3-, fluoride, which is a F-, and a bromide, which is a negative. Now, one main thing, and I put a star next to this, notice that the simple anions, are always named with the suffix IDE. Okay, so make sure when you're writing out the name that at the end of the nonmetal you drop the ending and add IDE. Okay, so again, put a star next to this. This is very important. Now here's a picture of how sodium is transferring its electron over to chlorine. Again, just like the reaction that I showed you earlier, it has the arrow going from that 1 valence electron from sodium over to chlorine. And again, notice that once it loses it on the right hand side, on the product side, sodium now has a positive sign above it, and that's because it transferred that 1 electron or lost that 1 electron, and now it is a complete octet. So the orbitals around sodium now on the outer edge is actually 8, a complete octet. Chlorine, on the other hand, gained an electron, so now it has a negative sign above it, and that red dot is actually representing the valence electron that sodium transferred over to chlorine. So now chlorine's happy with its 8 valence electrons. Now, writing an ionic compound has its own set of rules. So first, we're going to identify the charge of the element, and we're going to write them both out. So today we're going to deal with lithium and oxygen. Now, lithium is a +1 oxidation number, and oxygen has a -2 oxidation number. That's what they're called. Next, we're going to take the numbers, don't worry about the plus or negative, and crisscross them to the other element. So here we wrote them out without the plus sign in the middle. we're going to take just the numbers, not the charge, just the numbers, and we're going to crisscross it. So the 1 from the lithium goes in front of the oxygen, and the 2 from the oxygen goes in front, or as a subscript in front of the lithium. Now remember this, if it is a 1, kind of like what's going to happen to oxygen, you don't have to write it out. So when you write out this formula, it's going to look like this. Li2 subscript 2, again that 2 came from the oxygen, O, and there's nothing after it. Again, because it was a 1, we don't have to write it out. It's automatically known that the oxygen, there's a 1. Alright, so in an ionic compound, the charges of the cations and anions must always cancel out. Now, subscripts are used if more than one atom is needed to cancel out the charges. So, for example, sodium chloride. Sodium has a plus, chlorine has a negative. So they each have a just +1 and a -1. So those cancel out, and you have sodium chloride, NaCl. Lithium oxide, on the other hand, you have lithium with a plus sign and oxygen with a -2 oxidation number. So what happens here is, again, we're going to do the crisscross because they're not the same number, opposite charges. So again, the 2 from the oxygen goes in front as a subscript of lithium. And then the 1 from the lithium becomes the subscript of oxygen, but since it's a 1, you don't have to write it. Aluminum bromide, on the other hand, is aluminum has a 3+ oxidation number, and the bromine has a -1 oxidation number. Again, they're not the same number, opposite charges. So the 3 from the aluminum becomes a subscript of bromine, and the 1 from the bromine becomes a subscript of aluminum. Again, if you notice, aluminum doesn't have the 1 written in front of it because, again, if it's a 1, you don't have to write it. Zinc nitride. Zinc has a 2+ oxidation number. Nitrogen has a oxidation number of 3-. They're not the same number, opposite charges. And here goes. The 3 becomes the subscript of zinc. The 2 from the zinc becomes the subscript of nitrogen. Again, crisscross. Don't worry about the charges. Potassium iodide. You have potassium being a +1 and an iodine being a -1. Same number, opposite charges. They cancel out. You just write the elements themselves. Silver phosphide. Again, silver has a +1. Phosphorus has a 3-. They're not the same number, opposite charges. So the 1 from the silver becomes the subscript of the phosphorus, and the 3 from the phosphorus becomes the subscript of the silver. And again, like you see, phosphorus does not have anything written in front of it because it would have been a 1. You don't have to write it.